the feature tomorrow. Okay. So we talked yesterday about some basic elements of Java syntax in the form of expressions, and how expressions are used to compute values. Expressions are like formulas. They will compute a value, and that value can then be used to tell us how many people a given agent is connected, to determine whether or not a given person should be counted in a statistic, right? In contrast to Java expressions, which calculate values, Java statements do something. They change something. They change what's called program state. They update the state of the system. They modify something. Maybe what they modify is, for example, they change the color of a person, or they change how many people they're connected, or maybe they change their age, or maybe they make it so that the person is 1 year older, or any number of different things. They connect or disconnect people. Statements are, you could think of them as kind of commands. So you could tell it, return this value from a function, change the value of a variable, call a method, form another sequence of statements a certain number of times. Based on some condition, perform one action, otherwise another. Okay? So when AnyLogic seeks action code, this is an important principle. When AnyLogic seeks code for actions, it's seeking statements. So let's go take a look at an example there. Here, if we go look at this thing here, we have this entry action, exit action. Same thing with these, or the actions associated with these transitions. What it's looking for there is a statement. It's looking for statements. Help to what to do. It's not looking for a value. It's saying these are the things to do, the actions to undertake. Okay? And often we put more than one statement. Okay? These are some very common Java statements we'll be talking about. The if statement, for statement, while or do while, try, catch, finally, throw, an exception, and then statements that do things like assign, call to functions, which are actually, they apply functions which change something. And then there are some which enclose in a block like this, and in these curly parentheses, they enclose a bunch of other statements. They just undertake those bunch of other statements, okay? And handle any variables associated with them. So I should note that every expression in Java can be turned into a statement by putting a semicolon after it. This is an expression. We learned that sort of expression yesterday. But if you put a semicolon after it, it's a statement. It does one thing. It increments this. Now, it actually returns value, but the value is thrown away. The statement doesn't care about the value. It's just making this thing happen. So, yes, it has a value, but it's not being used. Similarly, you could have this. This would be a fine expression. And to put it into a statement, you could say this. Oh, look at that. Okay. Oh, it doesn't. Okay, that's interesting. I guess they don't actually. Okay, that's not obvious to me why it should rule that out. In any case, many expressions can just be put there, and if it doesn't change anything, it's not particularly interesting. But this is interesting because it changes something. It does something. So it's a type of statement. Okay. Okay. Let's talk about for statements. So for statements basically iterate. They go through a set of values again and again and again and again. And for each of those elements, they actually perform some action. Okay? They perform a statement. This whole thing is a statement, but there's a statement within this. And that statement happens, in this case, 100 times. Starting at 0, up to just before 100, so it goes 100 times. It goes 0 to 99. This statement will be executed 100 times. Okay? Unless it tells it stop the loop inside of there. Similarly, this one here will loop over each element of a collection and call that element A. So maybe we loop over a population and we call each of them A as a reference to an agent. And then using A, if the statement refers to A, it's referring to this A. Okay. Similarly, if this statement refers to I, it's referring to this I. Notice the variable declaration. It's actually saying we're going to use this variable I, which is an integer, and it's going to go from 0 to 100. Okay. So if we refer to I down here, it will know, oh, that's the I being iterated up here. Okay. So let me give you an example of that. We might say, for example, here, watch this. I will go and I'll put into main. I'll put it into main here. On startup, here we're sending a person a message, but watch this. I'll say for int I equals 0, I is less than 100, I plus plus, and I'll say trace ln I. So that will actually print out the values from 0 to 100, each on a separate line. So if I run this, here we go, print it out, boom, boom. Okay, there we go. 0 to 99. Print it out. Okay, so you see that basically you can refer to that element there, or alternatively, we could use this later loop that we have there, This later loop, we could say for person P in. By the way, the fact you could say person here is a nice feature of AnyLogic 7. Person P in population. I think it's called the population in there. Is it people? It's people. Thank you. In people, I want to print their name. Right. I want to print their name out. Okay. So this goes through, and every person there, it's going to print their name. Notice that I'm referring to P. There it is. All 10,000 people. Boom. Done. Notice that in each of those cases, the loop body, the thing in the loop, referred to the variable set here. So it's saying, oh, for each person called P, do something to P. And I'm saying, okay, print them out. Print their name out. Fine. It does it. Another thing I could do is I could send them a message or something like that. Okay? Now, if I want to put more than one thing in here, I do so with this. Then I could put several statements there. I could say trace ln, my name is, and put that on one line, and then I could say trace ln P. Right? Notice I have to put it in this thing. Putting it in these things makes this whole thing one statement. Whatever's in between these is one statement. Okay? If I just put it just like this, so let's contrast it. Let's do this. So let's run this one. What would happen? What would happen is we see it intermingling those names. There we are. Look at that. My name is. Great. Great. And meanwhile, if we had this, what do you think would happen? Well, only the first one would be in the loop. And you only hit the last one once. Watch this. In fact, it's going to cause a problem. Because the last one, hey, what's going on? Yeah, it can't even find it. Because it's not even in the loop and says, I don't know what P is. It's not inside the loop. And so it doesn't know what P is at the end. It'll be like this. The P is only defined here in the loop, in this loop body. And so by this point, it doesn't even know what it is. So if you want to do multiple things in the loop, even if you put them this way, it will pay not paying attention. It's good practice to indent the things inside the loop, but indenting doesn't help. It's just a human convention. It doesn't help it figure out what you mean. It's just for us as people. Okay? But it's don't not indent, because you need to indent, or else people won't be able to read the code. You need to indent inside of these things, and you'll see my indentation here. Okay, does that make sense? Okay, we're undertaking each of these tasks. Great.
I have this is a technical question. When you have an array, you can either do them with indexing, just a regular for.
Yes.
For each.
That's right. That's right.
Is there a gain in speed or something that?
For an array list, no. No, there's not going to be any significant difference between the two. There will be data structures where there could be differences, but in that case, there's not going to be a material difference. Just knowing something about how it's operating beneath the hood, so to speak, it's not going to be a big difference. You just have your choice. You can do it either way. Does that make sense? Yeah. Okay. Okay. So here we have. This is sort of all a big for loops, and notice this for loop is inside that one. So here we have one loop inside of another. So for each of these outer ones, for each value of the outer, in this case A, it's going to be executed the entire inner loop. D. Okay? It's going to be executed the entire inner loop. So it's going to happen again and again. So if I said, for int I equals 0, I less than 3, I plus plus, and then I said for j equals, or say go from 1 to 3, and then go j goes from 1 to 3 as well. And I were to okay, so sorry, this would be and if I would say trace ln, I times j, then it would do 9 combinations. So every value of I, all 3, every value of j, all 3. Okay. Okay, fine. Oh, I need the semicolon. Yeah. Okay, great. There we go. Boom. Okay. So let's try that. Okay. Hey, oh man, what did I do? Oh, there's something weird. It's pulsing at me in a most unseemly fashion. Okay, get. What does this have to do with get? What are you doing? Okay. Priesri, can you see something wrong here? Okay. I'm doing. See, it's pulsing in a most unseemly fashion. Oh. Okay. Oh, there's an L up there. That's what it is. Dumb L. Okay. 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 There we go. And here's all possible 9 values. Oops. View that again. Console. There's the possible 9 values of it. Right. Okay. Fair enough. So let's go through this. Okay. Another one is an if statement. So here it evaluates a Boolean. This is something like A greater than B, or A equals B, or A equals 0, or whatever it is. It tests something. If random true 0.5, then do this, otherwise do that. It does something, it changes something. Random true 0.5, send this person a message. Now you can write it like this. If all you care about is, okay, by default, we're going to do something if it is true, and otherwise we won't do anything special. We'll just so-called fall through. We'll just continue on after it. You just need this. Here, if it's true, it does this, otherwise it does that, and then it continues on. Here, if this is true, it does this, and then continues on to whatever is after it. People okay with that? Okay. Okay, so there's lots of cases of if logic, and often you'll see these logical conditions with and or. So and, remember that from yesterday? that means and. If this is true and that's true, so if this elephant is thirsty and they're at a water level or below, or sort of at sea level or below, then they can drink. If either of those is false, they can't drink, right? If the vegetation level is more than a certain thing, they're going to crush it. So that's that latter one. Okay. These are more complex conditions. This is bad practice to like string it up like this. This means something. It should be given a name, call off to function, and have a function say like is water, or you say is out of this is basically check if it is out of bounds. So this should be really, you should call a function. You should create a function called is out of bounds, and it returns this, and then you call is out of bounds or is water, and that would be much clearer. So it's when you see long conditions like that, you can read them. It's saying if this is true or that's true or that's true or that's true or that's true, but it's much better to give it a clear name, and you shouldn't expect to see things like that all the time. You notice the same condition down here. The basic same condition is basically there. If they had just defined an is out of bounds, you could have used it right here and here instead of repeating it in the same basic way. Okay. Right. So here, learning how to read these things. This is a function. This is a statement. It calls a method. So this method does something. It sets someone's velocity. And to what does it set it? It sets it to a value given by this expression, this formula. It sets it to this value shown in red. This move to method says move us to the certain location set by X, set by this thing on the left, Y, set by this thing on the right. Okay? So, again, it does something. Now, notice that woven into these statements are these declarations of variables. And remember that variable is just provides a brief name for a value. So this heading is called get my heading, the direction in which I'm moving. And that heading can then be referred to in subsequent code for conveniently. We don't have to call this method every time. We say get my heading, give a nice name to that heading for that value at whatever value it returns, 32.35 degrees north, and then and then 25 degrees east, and then I get that heading, and then I head towards that heading. Does that make sense? Okay, so woven into statements between them, and often at their beginning, are sort of declaration of names for values in the form of these so-called declaration of a variable. So then we can use that variable within this context, and then outside of the context of the function, or outside the context of the expression of the statement in which it's found, that value means nothing. Okay, so we don't have to worry it pollutes. So see this value here, heading? You don't have to worry. Outside of this, heading has disappeared. You can only use heading inside of this area. So it's declared inside of this if statement. So a heading is only bound. Its scope is this if statement. You can't use it outside of it. So you can refer to heading here, here, here. But if you were to refer to heading here, it's actually not. It's not that heading there. This heading must be another one from further up, because this one disappears. It's only used in this sort of area. So this count can only be used in this little area. You can't refer to it further down. Okay, it doesn't pollute the namespace. It doesn't interfere with other variables outside of that area. Okay, I'd like to introduce a while. Any question on that though? I'd like to introduce a while loop. So a while loop executes a statement as long as a condition is true. Okay, A classic one has the test at the beginning of it. A do while has the test at the end. So here, for example, you have a do while. This says do these statements, and it always will do the statements once, and then it will say while this certain thing is true. So it will always do it once, and then it may do it more than this. Okay, as long as the statement is true. And again, this is a statement in poor form. They should break this up to give a nice meaning, call a function, and the function would say is out of bounds, and instead of putting all this sort of verbiage there, so you'd say is out of bounds, and give it X try and Y try. Okay, now sometimes you see, we actually saw this today, a switch statement. I'll show you where we saw it. A switch statement was shown in this anemia and agents model, and it was in update current dose. So it was right here. Here's the switch statement. And I'll go put this up on the board, or on the screen. So here, we take in information on the patient we're treating, and we get information on the patient's condition. And if we're using an old protocol, then we take a look at the patient's state. This is the so-called switch. And basically we say, okay, we handle a bunch of cases, a bunch of situations. If the patient's in an unknown state, then we do such and such. And this basically says, okay, just continue on. If the patient is very high, then do this certain thing, adjust the thing, continue on until after the switch statement. If patient is in a high level of anemia, high level of hemoglobin, then we're going to reduce this and we leave the state. If the patient is in control, we won't change it. If the patient is low, we're going to increase it and go on, etc. So here we handle a bunch of different cases, and it's based on the patient state. So here we're getting this state that the patient is in. It's getting the state from the patient's state chart. And it's saying if the patient's in this state, do this certain thing. If the patient's in that state, do this other thing. So we can ask this thing, this is the state chart, patient dot, the name of the state chart dot, get active simple state, and it will return the state in the state chart that patient is in. And for each value of that, we could handle it in a different way. We could print something out differently. Here, the doctor of that patient is going to do different things to the patient. They're going to treat the patient differently based on the state that the patient is in. So the patient's state is going to be considered by the doctor, and the doctor is going to undertake different actions based on that state. And that's what this is capturing. Based on the patient's state, we do different things. That's the old protocol. The new protocol is this newer state. And what they showed in this little model, they demonstrated is that because of the dynamics associated with each patient, the old protocol of the doctor actively managing the patient was adverse. It was leading to adverse outcomes. In other words, the doctor was undertaking actions that were counterproductive. They were adjusting it without accounting for a delay and therefore worsening the patient's state. Yeah, it's a classic SD sort of thing. They weren't accounting for the fact that there was some delay before the patient improved, so they were feeding them more and more of these doses of things until it was too much, and then the patient would oscillate and go low. And then they'd say, uh-oh, we better undertake this other action. And so it was constantly swinging, and the new protocol involved basically nothing. You just keep them on the steady dose prescribed by the protocol, and that's it. They're over, keep them on that dose. Under, keep them on that dose, and it tended to smooth out to an adequate state. So here's an if statement. A switch statement can handle a bunch of different conditions, but you do need this break. This break basically says, Okay, now go after the if statement. We're done with the if statement. We're done with the if statement. Okay. So these are the rules, that the provider followed. Okay. Right. Another thing you could do is, in more recent versions of Java, you can handle strings. You could sort of say, okay, if the string is equal to this, do this, etc. And so you can have many clauses for example, to handle different strings. Here's another switch statement in mine, some of my code. So if it's a case of PIAC, do such and such. If it's a case of a connectivity matrix, do such and such. This break, you almost always see it. I'm not sure I've seen more than a handful in recent years where you haven't seen it. If you don't have break, if you forget to put that in, it just drops to the next one, and it's silly. It's silly. It just goes on and goes to the next case. And almost always you insert a break, and it says, okay, we've handled this case. Now we're done. Go to the next thing. Okay. So we're moving forward. That's composite statements we've talked about. Composite statements are really nice. There's one up here and one down there. Composite statements are nice because we can introduce new variables in them and do things, and then those variables disappear when we leave the composite statement. We do our work, we're done, gone. Boom. Okay. So variables can be declared. And the visibility of the variables just to the end. So this X try, Y try are only seen inside of there. They can't be used outside of there. Okay. Great. Yeah. Actually, one of the more important statements I don't have here, and I really should, and that is a return statement. So a return statement is associated with a function. So take this update current dose. We could actually go focus on it. Update current dose basically is determining the current dose, and it returns a value that's the current weekly dose in micrograms. So you call it, you say, compute update current dose, and it returns back what the updated dose is. Okay, that's what it returns. It returns a value, and the way that's specified in AnyLogic is you go up here and you say it returns value double. It could return any number of things. It could return could return the mother of the person as an agent or as a person, but in this case it returns a double value. To give other examples from this, they get hours requested for all patients. This totals up all of the hours required for all the patients, and it returns that. That total time in minutes divided by minutes per hour. So here, we just use it to return a value. Here's a computation for a particular patient, get minutes required for a given patient, and it returns it here, returns it here. This doesn't require a break because you're just returning out of it. You don't have to worry, you continue on. When you return out of this thing, you immediately leave the function. You don't continue on. You sort of call this function, it's doing its work, and then it returns and it comes back. It comes back to whatever called it. You don't have to worry that it will continue executing down there. So you just return rather than doing a break. So I could say, do this for me. It'll go off, it'll do a bunch of work, then it returns, immediately comes back to me with the value it's specified, if there is one, the value it's returned. Does that make sense to people? Are you feeling okay with what I'm describing? Okay, how about over there? Okay? Okay. Okay, now let's get into something a wee bit more complex that you'll sometimes encounter. Sometimes things go wrong while a model's running. And the way in which AnyLogic in Java, signal this is via means what they call an exception. It goes wrong in a way that, and it signals it. It says something's bad. Instead of just returning a value, it sends up a different sort of thing. It says something's bad. It's like pressing an alarm. It's like pressing an alarm. And that alarm is the signal something's happening. You got to handle it. Okay. So there's this thing called a try block. And you'll occasionally see these needed in, not so common in AnyLogic itself, but if you're going to use any sort of external Java things, you'll see this. And you'll try this, and then you can do what's called catching an exception. This basically says, like, I want to handle an alarm of a certain sort. And you can issue, say, if that alarm happens, I want to handle it in this way. And occasionally you'll find Java demanding one of these. It says you have to have one of these because this thing, what's in here, can throw an exception. And you have to then wrap it up in a try and a catch. And this catch will basically say, I catch this exception and I print something out. I print out, oh, something bad happened. Yes?
If you try, okay, so say you try that block because 3 things can happen.
Right.
Okay, then you have to have a catch for each of the 3 possible.
Or you can just have a catch for any exception at once.
Like an else.
Yeah. So here's an example. Try this, and then if there's this sort of thing that goes wrong, a number format exception, maybe you print out one sort of message. If there's an index out of bound exception, you print out another thing. So this is for a PyEC file. This is actually something I wrote to import PyEC files into AnyLogic to create networks based on PyEC files. And it tries to read a PyEC file, but sometimes it doesn't work. Sometimes the PyEC file is messed up. And so I actually give something, I say 2 numbers separated by white space were expected, indicating node information to be connected or what have you. Or index out of bounds, one or both individuals cannot be found within the network or within the list of people or what have you. So here we're trying this, and if something goes wrong, we handle it one way or the other way depending on what went wrong. Okay, and I wouldn't worry about this much, but just be aware that Java will occasionally, maybe once a year, if you're working heavily with AnyLogic, you might run into something like this. And what you do is you wrap it up in a try, and then you have a catch. And this catch could just say exception E, and you can handle all things with that. But you want to print something. You want to say something went wrong, so that the user knows it's not silent death. It actually says, like, something happened, I don't know what to do with it. And you can actually print out the information about what went bad. You can sort of print this out. It will say where things went bad. Which, if you show it to someone from computer background, they'll know they'll be able to sleuth what it means. It shows sort of at what context did it go bad. And we'll probably see that. Okay? Yeah.
The scanner that you have there is a jar library. When you're reading the information, scanner.
Yeah, that's a jar library. Yeah. You'll find it. I think this may be in the examples I've given you. I'm not certain, but I think it's part of it. It's a jar library that I attached to. Either that or it's part of standard Java. I can't remember, but yeah, I can't remember if it's part of standard Java or either that or it's a jar library. Yeah. A jar is sort of a Java library written by someone else that I can use, and there's huge numbers of these things. An example would be statistics library. And I just referred to it, and it's called the jar file. So I refer to that. Okay. Any questions about that? Questions? Okay. Maybe I'll just make a couple more related remarks, though. Okay. So we have right. This will put us in good situation for tomorrow. Good. Okay, let's talk about Java. So this would be Java methods. So this is a bit